Good day everyone. So for today's session, we will be discussing about the laws of exponent part 1. So for the part 1, we will be discussing about the positive integer exponent. Now, what is your observation? Number 1, e to the cube. Number 2, 2 to the fifth. Number 3, negative 3 squared. Number 4 is x to the 4. And number 5 is y to the cube. I know you have something in your mind. Now let's discuss. In general, if a is a real number and n is a positive integer, then a to the n is equal to a times a times a. And this is the n factors of a. So in our example, we have 10 to the cube. What happened is 10 times 10 times 10. 2 to the fifth becomes 2 times 2 times 2 times 2. So whatever be the exponent, that's the time that you multiply the base in by itself, by the number of the exponent. So where n is called the exponent, a is called the base, and e to the n is called the n power of a. So the first laws of exponent is this one. So let m and n be a positive integers. Then number 1, e to the n times e to the n is equal to e to the n plus n. Note that we have the same base. So if we have the same base and then we will multiply, then we will add only the exponents. So for example, we have y squared times y cubed. So what will happen? We will add the exponents. So we have y squared plus 3. So we got y to the fifth. The second one is if we have e to the m times n, so we will multiply only the exponent. So we have e to the n times n. So for example, so we have g to the cube to the fifth. So our base here is g, and our exponent for g is 3, and then quantity to the fifth. So what we did is we will multiply 3 times 5, and it becomes 15. So we got g to the 15. Another one is AB quantity to the n. So what we have here is a multiplication of a base. So we will just only distribute the exponent. So we have a to the n times b to the n. So we have this one, 3x quantity squared. So we will distribute the exponents. So we have 3 squared times x squared. So we have 9x squared. And for number 4, we have if a is not equal to 0, then e to the m over n is equal to 1 if m is equal to n. Okay? Take note of that. And then e to the m minus n if m is greater than n. Meaning to say, the m is bigger than the n. Okay? And then a to the 1 over e to the n minus n if our m is less than n. Meaning to say, n is bigger or greater than n. Okay? So for example, we have 2 to the 4 over 2 to the square. So the bigger one is 4. So we will minus, so 2 to the 4 minus 2. And then we have 2 to the square and is 4. Another one is, example is this one, 3 to the 5th over 3 to the 8th. So in this case, 8 is bigger than 5. So we have 3 to the 8 minus 5, and we have 3 to the 1/3. Okay. If number 5, if b is not equal to 0, then a over b to the n is equal to e to the n over b to the n. So for example, we have negative 2 over x quantity cube. So our a here is negative 2 and our b here is x. So we have negative 2 quantity cube over x to the cube. Negative 2 quantity cube, so we have negative 2 times negative 2 times negative x becomes negative 8 over x to the cube. Okay, so let's have another example. So in this case, we have this problem. So we have 3x squared y to the cube quantity squared negative 2x to the fifth y to the squared over negative 6x squared quantity cube y to the cube. So this is equal to, so we will distribute first by the law of exponent number 3, we will distribute the exponent. So we have 3 squared x to the 2 times 2, then y cubed times 2. Just copy. And then we have here x to the cube squared times 3, then y to the cube. So by simplifying, we got this one. Now another one is we will multiply. Okay, we will multiply. So we have 9 times negative 2, that is negative 18. X to the 4 times x to the 5th is x to the 4 plus 5. Then we have 6 plus 2 over this one. And by simplifying, we got this one. The negative 3 divided by negative 6, we have 3. X 9 minus 6. So y 8 minus 3. And we got this 3x to the cube, y to the 6, y to the 5th. So thank you. That's for the loss of exponent part 1. And for the exercises, you can choose one of these problems. Okay, thank you. This is Mr. Junarty.